Okay, so getting right to it, humanity's journey to Mars. It's not just a dream anymore. It's like an actual goal we can reach. And one of the things that might make it possible is nuclear thermal propulsion. I know nuclear can sound a bit scary, but this is really cool stuff. Imagine a rocket engine powered by a nuclear reactor, heating a special propellant like hydrogen to temperatures hotter than some stars, thousands of degrees. And that superheated propellant blasts out, creating thrust that can, propel spacecraft much faster and further than chemical rockets ever could. And get this, a company called General Atomics Electromagnetic Systems, or GA-EMS, working with NASA, has made a big breakthrough. They tested a new fuel that can survive inside an NTP reactor, and these conditions are insane. This is normal fuel. It was subjected to 2,600 Kelvin. That's almost half as hot as the sun. And it's not just the heat. It also has to deal with superheated hydrogen gas, which is incredibly corrosive, rushing through the reactor. This new fuel has to resist that, and it passed the test. This is huge. So why is this such a big deal? Because efficiency is, like everything in space travel. And NTP is 2-3 times more efficient than those chemical rockets we've been using forever. And that means a lot for missions to Mars. First, we're talking way faster travel times, so less radiation exposure for the astronauts. And, maybe even shorter missions overall, which would be a huge plus, right? But there's more. Using less fuel means a lighter spacecraft. Maybe we won't even need multiple launches and like that crazy in-space refueling. It just makes things simpler, Missions to Mars more, well, doable and maybe even cheaper. Now, you might be thinking, okay, this is all great, but what's the catch? Well, building a nuclear thermal rocket engine is a massive project. It's complicated. Lots of engineering challenges to figure out. I mean, think about it. We're basically putting a nuclear reactor, a controlled one, of course, on a rocket and shooting it into space. So safety is the biggest thing. We got to make sure that that reactor is shielded, to protect the crew from radiation. And remember, this thing's running at crazy high temperatures.
The materials we use have got to be tough, able to handle that heat without any problems. And then there's testing. Before we even think about putting astronauts on this thing, we need to know it's safe, right? So lots of ground testing, pushing the engine hard, getting data, and working out any kinks, and eventually test flights. Maybe unmanned missions, just to really see what it can do. And we can't forget about how people feel about nuclear stuff. We need to be open and honest about the risks and the benefits of using nuclear power in space. Getting people on board and being transparent every step of the way, that's key to making these missions work. But look, the potential of NTP is just so huge, so game-changing. It's worth all the challenges. If we can figure this out, it could totally change space travel as we know it. It's not just about getting to Mars. It's about opening up the whole solar system. I mean, imagine missions to Mars taking months, not years. Imagine sending probes to the outer planets so much faster. Imagine us actually living on another planet, maybe even further out than Mars. It's a big dream, but with every successful test, every breakthrough like this new fuel, it feels more real. And it's not just about the science and engineering, right? It's about something deeper, that human need to explore, to see what's over the horizon, to push the limits. I mean, for centuries, we've looked up at the stars and wondered, are we alone? What else is out there? And now with stuff like nuclear thermal propulsion, we're actually getting close to answering those questions. I mean, really close. So as scientists and engineers keep pushing, as we get closer to actually launching a nuclear-powered spacecraft to Mars, I want you to think about this. What will your part in this be? Will you be watching, excited about every new thing? Or will you be inspired to contribute, to use your talents and passions to help make this happen? Because this isn't just about sending a few astronauts to Mars. This is about understanding the universe better, pushing ourselves further than we ever thought possible, creating a future where the stars are truly within reach. That's the potential of nuclear thermal propulsion. And that's what I wanted to share with you all today.